Okay, so once again, I'm going to write down SOHCAHTOA at the top. And notice the placement of like the O and the A and the H. It's telling you the numerator and the denominator for that ratio. Okay, so if we start with number 5, it's telling us determine the remaining trigonometric ratios, leave answers as exact. Use simple radical form when necessary. So the first thing you want to do, it says hint, start by drawing your right triangle and find your missing side length. So let's go ahead and start with that. So I've got A, B, and C. And I've got cosine of A. So I'm looking at this angle, and cosine is A over H. So adjacent means that it's touching that angle. So this side right here is actually touching that angle. And it has to be over the hypotenuse, and so we're looking for this side over here. 5 squared plus B squared equals 9 squared. And I've got 25 plus B squared equals 81. If I subtract 25 from both sides, I get 56. If you do a factor tree for 56, you'll get 4 times 14 is one of your possible factor trees. And then this goes into 2 and 2. So my answer is going to be 2 root 14 for that missing side. And now I've got my missing side, so I can figure out what the other ones are. And so I've got cosine, so I got to figure out sine and tangent. So sine of A is opposite over hypotenuse. So 2 root 14 over 9. And since the radical is in the numerator, I don't have to rationalize that. And then my tangent of A is TOA, so opposite over adjacent. And again, I don't have to rationalize that. Okay, with number 6, they're giving you the tangent of B. And this is my angle. 4 over 7 TOA, so 4 opposite over 7 adjacent. And I've got to find my hypotenuse when I do the Pythagorean theorem. So 4 squared plus 7 squared equals C squared. 16 plus 49 is C squared. 65 is C squared. And C is the square root of 65. If you do a factor tree for 65, it's not going to get you anywhere. That's the most reduced that you can get. So that's going to be the square root of 65 for the hypotenuse. And I've got tangent, so I've got to figure out sine of B and cosine of B. Sine is opposite over hypotenuse, so 4 over the square root of 65. Or if you rationalize that, that's 4 root 65 over 65. For the cosine of B, it's adjacent, so 7 over hypotenuse, square root of 65. Or if you rationalize that, 7 root 65 over 65. For the last one, notice it says sine of C. Even though it says sine of C, I'm not going to continue with this triangle Your C, whatever variable they give you, can't be the right angle. So I'm going to make a little statement. Even if it says C, it doesn't matter. So this is not the right angle. So when I make my triangle, I'm just going to change my position for the C. So I'm going to just go A, B, C. Just make sure it's not, whether you're given A, B, or C, or D, or E, or F, doesn't matter. It can't be your right angle, okay? So I've got C is over here, and I've got the sine, so that's the opposite over the hypotenuse, and I got to figure out the other side of this. So 5 squared plus B squared equals 11 squared. 25 plus B squared equals 121. If I subtract 25 from both sides, I get 96. And if I do a factor tree for 96, I get 12 and 8 is a possibility. And 4 times 3, 4 times 2. And it looks like I have a group of 2 right there. So it's going to be B is 4 root 3 times 2, because those are your leftover. Those are 6. So this missing side is 4 root 6. And now I was given sine, but now I can find cosine of C, and I can find the tangent of C. So for the cosine, it's adjacent. So 4 root 6 over hypotenuse. And luckily, the radical is already in the numerator, so I can leave it like that. And then the tangent of C is TOA, opposite, over adjacent. And if you rationalize, you would multiply the top and the bottom by the square root of 6. And then remember, at the denominator, that'll become 4 times 6. So that'll be 24 at the denominator. Okay, for the next section, we're going to use this triangle, but we're going to use variables. We're not going to have numbers when we figure out the sine, cosine, and tangent. So for the cosine of A, I'm looking at this angle right here. That's my cosine of A. And I've got cosine, which is adjacent, B, over hypotenuse, which is C. My sine of A would be opposite, A, over hypotenuse. So are those equal to each other? No, this is false. That's what we're figuring out. We're figuring out if the statement is true or false. Now, the only time that this would be true, the only exception would be if A equals B. So if, let's say, both of those sides are 4, this is 4 and this is 4, then yeah, that statement would be true. But that's the only time that would be true. If I look at sine of A, I've already got that from up here. So A over C. And then 90 minus A, don't let that trick you. If we look at angle A and we look at angle B, those are complementary because the triangle sum theorem tells you that all 3 angles are 180. But if you take out C, which is 90 degrees, then A plus B is 90. So what happens if I subtract A from both sides? Well, that just gives me B. 90 minus A is B. So really what this is just saying is cosine of B. That's what it's saying. So, all right, now let's figure out the cosine of B. B is a different reference angle. It's over here. So my cosine of B would be adjacent over hypotenuse. So that's my adjacent, that's my hypotenuse. And that's A over C. So that is true. All right, number 10. We've got A is our reference angle. So we're coming back over here. And it's the tangent. So tangent, TOA, opposite, over adjacent. And now I'm looking at my cosine of A, which my cosine of A is up here on number 8. I'm just going to look at that. So cosine of A is B over C. And then sine of A is A over C. So what happens is you're really just dividing two fractions. So B over C divided by A over C. And then if you remember, when you're dividing fractions, that's the same thing as multiplying reciprocals. So B over C stays the same, and then we change this, we multiply the reciprocal. So let's change that. That's going to become times C over A. And what happens here? You've got the C's cancel out. You get B over A, but that's not A over B. That was your original one. Tangent of A is A over B. So this is false. But in little parentheses, all right, they are reciprocals of each other. Because what happens, your A and your B are switched. First it was in the numerator, A was in the numerator, then it went to the denominator. And same with B. First it was in the denominator, then it went to the numerator. And then the last one, tangent of A. So I've got that. A over B, 1 over the tangent of B. So I'm going to look at this reference angle over here now. TOA, B divided by A. And again, I'm just dividing a fraction. So what I do is I multiply by the reciprocal. And A over B is the same as the original, so that turns out to be true.